Hi, and welcome to this video where I'm going to explain what covalent bonding is. Now, covalent bonding is a really important type of bonding that you find between nonmetals in any kind of molecular compound. So it becomes very essential in any kind of organic chemistry, and more importantly, it becomes a major talking point when we start looking at the structure and bonding external standard. Okay, so covalent bonding is a type of bonding that occurs between nonmetal atoms. Now, nonmetal atoms have incomplete electron shells, so they might have 4 or 5 or 6 or 7 electrons in their outer shell. Now, if you think about the octet rule, we know that atoms want to have a full outer shell of electrons to make them stable. And nonmetal atoms, because they've usually got between 4 and 7 electrons in their outer shell, want to gain electrons. But when a nonmetal bonds with another nonmetal, they both want to gain electrons. There's no way for both of them to gain electrons off each other, because then one of them would have to lose an electron, and they don't want to lose electrons. So they share electrons instead. It's kind of like if you and your sibling have a shared toy. Both of you want it. Neither of you is willing to give it to the other one, so you have to learn to share it. And just like that kind of sharing of electrons between atoms is not always an easy or fair process. Okay, if we think about our shared electrons for a moment, we can do some very simple molecules. You think of something like chlorine gas, where you've just got 2 chlorine atoms and they share an electron each, and away they go. They've got a very simple molecule. Hydrogen gas, H2. The bonding between those 2 hydrogen atoms is covalent bonding. And then we can get up to some very, very large and complex structures. Think polymers, diamond, glass, all sorts of things like that. There can be 2 or 3 pairs of electrons that are being shared between elements, which leads to double or triple bonds. And with this, you can then end up with a massive range of compounds, because once you start realizing that you can share electrons, then the possible combinations become almost endless. And that's one of the joys of organic chemistry. Okay, so here's some simple examples. Okay, up the top left, we have some structures that you might be reasonably familiar with, or you may have seen: water, H2O, ammonia, N, nitrogen and 3 hydrogens, carbon dioxide and methane, some fairly simple molecules. Each of those straight lines represents 1 pair of electrons that have been shared. So in the carbon dioxide, there are 2 lines between the carbon and each of the oxygens. That represents a double bond in each case. So those are simple molecules. On the right-hand side is a section of diamond, where each blob is a carbon atom and each line is a shared pair of electrons. And you can see that it's quite a different sort of a structure than what you will see with the simple molecules. Okay, so top left you've got molecular compounds. The bottom right, diamond, is a covalent network solid. Okay, so molecules are generally relatively small. They are discrete bundles of atoms. So in chemistry, particularly at junior levels, often the word molecule gets bandied around a lot, and it gets used in all sorts of contexts, sometimes not correctly. So a molecule has a discrete number of atoms. You should be able to look at it and go, yes, that has 1 oxygen atom and 2 hydrogen atoms bonded together. That is a molecule of water. It doesn't include structures that have no fixed limits. So things that, like a large network solids or lattices, do not form molecules. Okay? So when you have a molecule, the molecular formula will tell you exactly how many atoms are present in that molecule. Okay? So carbon dioxide, for example, has 1 carbon atom and 2 oxygen atoms, and that's it. This is very different to, say, an ionic compound or a metallic compound or a covalent network solid, where they have incredibly large numbers of atoms, and we don't count them because we don't think of it as a discrete unit. We look at how many, the ratio of different types of elements to each other, but we don't look at it as a discrete unit. Okay, so when we talk about a molecule, we are talking about a single small unit of something. So that's where I'd like to leave you with covalent bonding today, just the idea of what is a molecule and what is a covalent bond. So covalent bonds, shared pairs of electrons, and a molecule is a discrete collection of atoms that have covalent bonds from shared pairs of electrons. I hope I'll see you back soon where we talk about some other aspects of covalent bonding and different types of bonding. Thanks very much. See ya.